Hi, this is a brief overview of a Python program that I wrote. I call it CIVA, as in seaside or sweet sea, PRIVA. In Suite B, PRIVA controls and monitors not only the fertigation but also the environmentals of the rooms. And therefore it can provide us with all the data in tabular or graphical form. In Suite C, the cultivation team keeps a handwritten log of the environmental data from the gPod units in the hallway. I take that data roughly weekly and compile it into a spreadsheet that this program queries to present the data in a graphical format in a way that PRIVA would. With one added bonus that PRIVA does not offer, which is that it considers the generations of our clones, such as M99, M100, blah, blah, blah. The odd numbered generations are grown on Suite C. So just to go over kind of what we have here, I imported the pandas package and the matplotlib package, aliased them as PD and PLT respectively. Then it reads the Excel file, parses the dates from numbers to actual readable dates. Then it's going to ask for an input of the generation that you want, asks if you want to do a comparison or not. If you do, it will ask you for the generation which you want to compare. And then it will save the file as a PDF. If you do not want to do a comparison, it will show you a single graph. So without further ado, let me just kind of show you a run through of a couple iterations of what you can do with this here. You start by typing Python space CIVA.py, hit return, and then you get the prompt for the first input, generation. Minimum is M85, that was the first generation which we were gathering data. Odd number generations, because that's all that is in Suite C, and it is case sensitive. So let's do M85, return, compare, yes or no. We will start with no. Then you are prompted to tell whether you want the minimum, maximum, average of the environmentals or H2O information. Let's start with average. So you can see here we have the graph of the data presented here with air temp average at top, relative humidity average in the middle, and CO2 average at the bottom. Now, were we to run this again, Python CIVA.py, this time we will go to M99 because that has the most fertigation data. This time we will again say no to the comparison. This time we will request the H2O, and what we get here is graphs of the test pitcher, pH, and EC as it was recorded over the course of M99. These are all labeled based on the input variables for generation, etc. Now let's do it again, showing a comparison. Python space CIVA.py, enter, return. This time we will say, let's look at M87, compare, yes. Generation for comparison we will say M99, return. And when you do a comparison, it asks for environmental or H2O. The environmentals is simply defaults to the average. Also, if you were to hit return here without typing an input, it also defaults to environmental averages. Let's take a look at that. So what you get here is now two sets of graphs labeled by your two separate generational variables, M87, M99. As you can see, different curves here. They are labeled with circular tick marks on the first figure and X's on the second figure. The tick marks are to show the actual data collection points, whereas where the line has no mark, that is just a connection between data points. The marks are there to avoid any assumptions of data points that were collected when they were not. Last but not least, if we close these here, and I will make one last foray over to my folder here. If I go into my CIVA reports folder, you will see these PDF files of all of the reports, which are named by the program based on the input variables for generation and whether or not you want a comparison, water, environmentals, etc. And all of these are PDF files that can be shared if necessary. And I will keep building this out and changing the feature set as I come up with new ideas. Yeah, that's about it, guys. Hope you liked that. Thank you very much.